Assalamu alaikum. I think good morning, you have caused good afternoon to all. First, I would like to thank you the opportunity in this FEDA and as a keynote speaker. So, Sir has mentioned our Dr. Ponsar has mentioned about this uh, global warming. Because of the global warming, only five important elements affected, you know very well. That is for air, water, and fire, and land, like soil, and etc. So everything is we are Sir has mentioned this. That is the information about this statistical reports Sir has mentioned, and similarly further what happened, how we can avoid everything. But as a researcher and as a professor and as an academician and similarly for industrialists, we have to give for a solution. So that is important one. We have to move for the in this our world. So for this part, we are I'm very professor in this our question tsunami using the triple SIM models. So tsunami, already we know that the tsunami affected all over the world in different places. Recently, particularly because of the global warming, so a lot of the tsunami affected in the Japan and Indonesia and other that is Atlantic Islands. A lot of the places also they were affected. So in this forest, what are the as a human being we have to save for our life for this human and other things because the global warming created by our that is our human being only. Similarly, for the solution we have to give. That is our duty. So that's the reason only now all the research that is moving towards forward for the solution. So this type of tsunami we know already we know that this type of tsunami we have. The tsunami can be categorized in different parts. That is first one earthquake tsunami, then volcanic tsunami, landslide generated tsunami, and mega tsunami. So four types of tsunami we have. So in this phase, the each and every tsunami we have three phases available. First one generation, next one propagation, and third one runoff. So before the earthquake, because of this fault line and because of the under the earth we have some other chemical reaction and technology create effect. There's generation is happen. Then because of the generation, the water is very nearly more than 100 kilometers of height is come to the in this our land. That's the propagation and runoff is automatically because of this land and based on this land structure, the runoff is height is more. That's the reason only we have affected in this all over the world. So this is what we have the face of tsunami. So tsunami protection by the agency in this all over the world, different type of the agency also moving in this to give for the awareness, similarly for the tsunami warning also we have. Tsunami warning center, particularly for this geology survey also we have, and other part of national earthquake hazard detection program also is conducted for each and every places to give the prediction for the tsunami. And what is the detection of tsunami? We have the following for the this type of this approach. The first one that is for we have this that is one there is a top system. The top system is connected with the satellite. The satellite connected with this office. That is the control system of our tsunami warning center. So changes in these the waves of the tsunami or the waves in the sea. Automatically the information is given to this top system. Top system gives for this our satellite. Satellite gives the information to this particular control room or control of this system. So other than there are people that is the dark office will do the information and warning to the other. So these are happening all over the world. Similarly, for this type of this point also mentioned is different places the dark system is available in particularly for Australia and similarly for a lot of places more than 89 dark station available all over the world. So what is the limitation of the tsunami early warning system? Because already we have the tsunami warning system, and what is the problem with the tsunami warning system actually? So what is the limitation what we have in this tsunami warning system actually? The tsunami warning system is created by this each and every government under the one that is for the agency. But this early warning system is very important means because we have to save the life similarly for you that some important information about the particular zone area peoples. But what happened in this particularly in the tsunami warning system is there is a false warning system is mentioned. So at that time, the people is affected many more. And is there is some information also we received. That is the tsunami will come. Tsunami we expected. Like that information we are received from the tsunami warning system. But it's not true. Sometimes it is 5 years. So this part we have to move for the next one. This is solution. So what is for example, it is our warning we have, in particularly for this in the particular area in Indonesia and other time also, lot of false alarm or lot of the false warning system is mentioned there. So that's why the alternative solution and we are moving for the next level, that is for the mathematical solution. So that's why the need for tsunami modeling. In the tsunami modeling, you have the primary purpose of the tsunami modeling. We have the purpose of the modeling is the risk assessment, and next one the early warning system, and the hazard mapping and the land using planning. Then engineering infrastructure design and education and awareness. So, the objective of this research, objective for this tsunami warning is forecasting of the tsunami we have to find the earliest arrival time of tsunami. Next one, using a minimum number of input parameters, because at the time of the sudden happen in this particular time, we are not possible to get for the all the parameters. With all the parameters only, the early warning system is give the input. That's the reason only we have delayed information we received. So that's why we use a minimum number of input parameters, and we are possible to give for the solution, that is important one for the minimum input parameter. Next one, to reduce the computation time. That is, after completing this, our using for our simulation modeling and using for our computer, our software, it is due for the solution within the 5 minutes. Thank you. Uh, so that's the reason only this we have to apply for the both the distance and the local tsunami. We have the two important part we have. Apply for the both distance and local tsunami, and apply for the long duration tsunami also. So the impulsive model is an overview of we have created for the new model by this our team actually for the three part we have what I mentioned, the generation phase and the propagation phase and run phase. So the other part we have this created for the our simulation modeling using for our Python programming, and similarly for the algorithm also we have that is important. It is the impulse source based model, impulse and fault line based model, impulse estimate short distance based model, and impulse AB model, and impulse ADIR model. So this is a gap what we have identified, because before that I mentioned previously, the lot of the agency also doing for the different type of this simulation modeling, similarly for the early warning system also. So in this part we have the most, and tsunami 2 is a model already now, and one wave and continuous wave and contact also we have. So what is the gap we have identified not accurately captured because of this most, similarly for this limits its that is applicability and not very efficient and requires specific input parameter and ideally for the condition and may not capture. And these are the things, the disadvantage also available in the previous what we have in this identification existing part. So the advantage is the mean approach also we have, that is as I mentioned previously, the minimum parameter we are possible to identify the tsunami that is arrival time. And next one important is that is for this our similar to long duration or long scale tsunami, computation time is less than 5 minutes equal to you for the solution for this one. So that's the reason only we have advantage and the approach in this our next one the methodology. We have the six important stages we have. First one data collection, next one the parameter identification and mathematical equation modeling, and the program for equation and implementation and testing. So these are the steps we have crossed. So this is the step one data collection. We have data collected from this all over the world. What is important is of the government agency and other agency also we have collected using the bulk metric data, earthwork data, and other data also. Similarly, for the parameter we have identified that is a technical point, because that's why I want to skip some other point, because magnitude and origin location and focal depth and deep angle, other things also we have. This is a technical part. So all the part we have considered for the civil part based on this 5 input parameter only. But usually to develop for any modeling, minimum 15 parameters, more than 15 parameters required. Now we have identified, we have created for the algorithm, and so that is using for the Python and other algorithm, other program coding also. We have identified only 5 parameters enough to do for the solution of the tsunami arrival time as earliest arrival time also. So this is a mathematical formulation. This is a that is using for the representation of three-dimensional combinations we have. And next one, that is for the initial condition we have considered for the initial condition, that is the seabed is rigid and velocity seabed, the depth of the seabed, and the next one the fluid is fluid conditions, like that we have considered for the some initial condition. And the phase two, that is the generation, and we have you should see that this is the framework for the there is generation, we have the seismic movement, and all the part we have considered. There is a great boundary conditions and with rupture zone determinations, supersymmetric wave propagation, etc. So output we have from the phase one, there is rupture zone coordination, rupture length, and type of rupture, and etc. These are the things we have received for the first one, that is for the phase one generation. Similarly, for the propagation phase also we have this identified and we have that is completed for the propagation part also. And third one, there is a run-off phase. Again, the run-off phase we have a framework. These are the framework, use the framework, and we have identified the third stage, that is for the run-off phase also. So the generation and propagation and run-off, so all the part we have completed for this our that is the algorithm and for the solution also. So next one, there is for the propagation for the modeling. We have already mentioned that using for the Python and other algorithm, more than 6 algorithms we have integrated, and apart from that, we have identified the new 4 algorithms and nearly 10 algorithms we are using to use the predictions of this tsunami propagations. So this is the implementation and the final part. This we have identified and we have that is the mathematical formula and mathematical application also completed. But the problem is how we have to implement. The implement part is really important. That is that we for the solution using the some simulation part. That's the reason why we have implemented for the 5 different parts. First one, the location based we have identified. And similarly for the ocean based also we have identified, for example, North Atlantic, North Pacific, Indian Pacific, and next one for the continent based also. For example, Europe, North America, Asia, and South America and Asia also. Last one, the country based also we have identified. So different type of this implementation we have, and that is applied. And one more important I would like to mention here, we have integrated with this National Institute of Ocean Technology in India. There is a Institute of Science, and we have cooperated with this MOE, and this, we have completed for this part. So these are case studies for the, for example, I will show for only 2 case studies. First one for the Indian Ocean tsunami 2004, what happened, and how we have identified this parameter, what is solution we got. Okay, this is the 9.3, already we have the 9.3 map that got stuck in this December 26, 2004. Nearly now 2024, we are 2004 now. So at that time, we have 9.3 earthquakes stuck in Indonesia, and a lot of the people, lot of the people is dead because of this the sudden tsunami. So we have tsunami simulation result. We got it using my algorithm, using this simulation model. The first one, that is for the generation of steady area and seabed displacement, and next one for the rapture line. We have the rapture line towards nearly 1,000 kilometers, 1,200 kilometers from the particular part to this Burma plate also crossing. So this is important part. Next one is the seawater deformation and generation zones. Then propagation phase also similarly further. Now I am going to identify my Chennai to our that is for the Sumatra. The Sumatra to Chennai, what is the distance? The short distance also we have identified. And how to reach for the particular time, the earliest arrival time, what is the short distance? Is based on this algorithm, we are possible to give for a solution of the short distance also we have identified. And similarly for next one, it is the impulse aiming approach. Based on this impulse aiming approach, we have identified the totally 8 directions based on north, northwest, northeast. Similarly for south, southwest, like that. So now we are in this from this that is west northwest. Also we have identified for the northwest approach. In the northwest approach, we have this each and every there is hours. You have the solution. That is for first one, second simulation, and third simulation stage, and fourth and final. So what are the how the distance is moving and how this each and every stages that is waves are moving. Everything you have mentioned here. And similarly for the impulse ADR approach, in the ADS approach also we have used for the 360 degree. In the previous one I have mentioned only for the some direction that is maximum for 45 degree. But here 360 degree what happened in this after this effort and how we reach for the ADS arrival it is the impulse ADR approach. And next one impulse ADR approach for the Japan tsunami 2011 also we have identified and we got this output like this only. And this is the some validations of the value tsunami details. There is a train travels the location and the model of data, historical data, time difference, what will the accuracy we need, that is based on this algorithm, really get algorithm and modeling, we got this 99% for the first location and second location 92, 97, 90 and 95. Within the 5 minutes, we are possible to give for the solution for the earliest arrival time for the people. Is as compared to this our that is our yearly warning system is very useful for our people. As a result, we have created. And similarly for the estimated tsunami wave carriers also we have based on this run-up and maybe similarly for the travel time, everything we have calculated. And finally, another one basis that is for the two phases comparison here. So listen here 2004 Sumatra tsunami and 2011 Japan tsunami. In this, here the magnitude is 9.15, 9.1. But the fault length is different. So based on this fault length and based on the water depth, the total, that is the simulation models totally is it reflect for the differently. That's the reason only we have to consider for that are important point only. And propagation phase also we have this representation of propagation phase, how is occurring in 2004 and how is the 2011 and etc. And next one run up also similarly for the run up it is a presentation also we have that is for the graph representation also we have the slot release in the Chennai and Kanyakumari in the coastal of Tamil Nadu and India. What is the conclusion is the particular one. There is a minimum input parameter for forecasting of the tsunami behavior, and the tsunami can simulate using the primary available. What is the value we have? Based on this one, we are possible to predict the particular case. And these are apart from that, we have created for the designs of the prototype model also we have created to understand our student community how is happening and how we have to movement of these efforts like generation, propagation, and etc. So these are the water displacement mechanism also we have the pattern also we have tried upon the pattern. Future scope, apart from that, we have using for the another one model also we are going to implement that is for the three-dimensional tsunami wave and solar automata. Thank you for your listening and thank you for watching. So, any clarification you need? Thank you.
Thank you, Dr. Syed. Finally, I would like to invite Dr. Samiullah Khan with his keynote speech.
Can I have a mic, please?